Hi dear students, welcome to our channel Maths with Panindra. In this video, complex numbers question, JEEMCET EAMCET type questions for the preparation plan 2023, dear students. So here the question is, if A equal to cos 4 pi by 3 plus I into sin 4 pi by 3, then mod 1 1 1 determinant, not mod, determinant 1 1 1 1 a square 1 a square a equal to, options are provided: purely real, purely imaginary, complex number, rational number. So here first we need to simplify the value a into cos 4 pi by 3 plus I sin 4 pi by 3. Sin 4 pi by 3, cos 4 pi by 3, I will give the information. Cos 4 pi by 3, cos pi plus pi by 3, cos pi plus theta minus cos theta minus cos pi by 3. Pi by 3 means what? 60 degrees. So, minus 1 by 2. Similarly, sin 4 pi by 3, sin pi plus pi by 3, sin pi plus theta, third quadrant, sin negative. So, minus sin pi by 3, minus root 3 by 2. So, values we got it. So, therefore, the value of A will come A equal to minus 1 by 2 plus I into minus, so anyway here we are getting minus root 3 by 2. So, did you observe, dear students, this value in complex numbers? We can write like this also, no? Minus 1 minus I root 3 by 2. Am I right? So this is the value of omega square, one of the cube roots of unity. So x cube equal to 1, x equal to 1 power 1 by 3. So cube roots of unity. Cube roots of unity are 1, omega and omega square. These are called cube roots of unity. Among these 1 omega square, this value is omega square. And what is the value of omega? We know that, or we have the value. Omega equal to minus 1 by 2 plus I root 3 by 2. This is the value of omega. This is the value of omega square. So what is the need to write these values? That what I am coming. A value we are getting omega square, no? So wherever A is there, omega replace. And in the cube roots of unity result, we have one more result, omega cube equal to 1. So the given determinant value will comes determinant of 1 1 1 1 A value omega square. A square, here only I am writing, A square means omega square whole square only, no? That means omega power 4. Omega cube into omega, we can write it as omega. So, A power A square value is omega. So, wherever A square is there, omega, you write it. Next, 1, A square means omega. A means omega square is equal to. So, how to expand this? By applying row operation, R1 tells to R1 plus R2 plus R3. So this will becomes 1, 1 plus 1 plus 1, 1 plus 1 plus 1, it is 3. 1 plus omega square. Again cube roots of unity result we are applying. 1 plus omega square is equal to 0, dear students. So 1 plus omega square plus omega, that value is 0 only, no? 1 plus omega square, that value also 0. So now R2, R3, rest of them you can leave it like this. 1 omega square omega, 1 omega square. So expanding this 3 by 3 determinant. So 3 times of omega square into omega square, omega power 4. Omega power 4 means what? Omega minus omega into omega square. Once again, dear students, omega square into omega power 4. Omega power 4 can be written as omega square, omega cube into omega. Omega cube value 1. 1 into omega is omega. What is omega value? Here omega square value we have and omega value also we have. So 3 times of omega value, this one minus 1 by 2. Otherwise, I will write it here clearly. Some students not able to see, I hope here. So 3 times of, keep bracket, omega minus 1 by 2 plus I into root 3 by 2 minus omega square. So multiplying by minus plus 1 by 2 plus I root 3 by 2. Minus 1 by 2 plus 1 by 2 get cancelled. 2 times of I root 3 by 2 is only I root 3 by 2. So 3 into I root 3 by 2. So 2 times of by 2, 2 to get cancelled. So I into 3 root 3. So exclusively imaginary part it is. So the value of this determinant is exclusively purely imaginary. Purely imaginary value. So the given determinant value is purely imaginary, dear students. I hope you understand. Thank you for watching. If you like really this video, please press the button, like and share to your friends. Thank you all. We'll meet with a different question in the next session. Now you are able to see, dear students. Thank you. So this is the way purely imaginary answer will come.